First up, we've got Chris Emmott. I first met Chris at Equinox, which is a student-run organisation here at Imperial who deliver cost-effective solar energy in rural Africa. Chris works on modelling the potential for solar technology to tackle climate change, and he's also a student here at Imperial. It's making him the ideal candidate to talk at such an event. So, Chris?
Let me just get this presentation up. Okay. All right. Let's see if this works. Okay. So I'm going to be talking a little bit about, as you said, how solar power can help us reduce our carbon emissions and combat climate change. So just how everything got started in solar energy. So solar power has been around for quite a while. In the 1860s, the French were proposing this as a solution to very expensive coal. Later, in the 20th century, the US were developing and researching into this area to try and solve the problem of energy security and reliance on foreign oil. In 1954, the silicon solar cell was developed. You can see just there. And this was found to be quite a kind of a simple technology which could directly convert solar energy into electricity. And this was quite an expensive technology to start with. So it only really found applications in off-grid power, such as satellites, and very remote communities where conventional generation was very expensive and very, very difficult to manage. So the real principal motivation for the development of the technology was getting it cheap and getting it as cost-effective as possible. But now we're actually starting to ask something different of solar technology. We're asking it to provide us with clean and low-carbon power. So if we carry on, the past kind of 10 years, this has really been taken up, and a lot of countries have actually put a lot of effort into promoting solar power in order to try and create our transition to a low-carbon economy. This development has almost predominantly been based on crystalline silicon technology, which is a reasonably difficult technology to actually manufacture. It requires quite a lot of steps in the processing and quite very, very high temperatures in order to manufacture a solar panel. Something I forgot to mention also, so in the past 10 years, we had a rapid growth in the amount of PV systems deployed, and we're now up to around 100 gigawatts of capacity, which is roughly equivalent to around 20 nuclear-fired power stations. And in Germany, this is, which is kind of the biggest market historically, PV is now supplying 5% of the electricity in the grid. So, getting on to why this is a low-carbon power source. So the manufacture of any kind of technology or any energy technology requires resources and energy, which in our carbon-intensive world produces carbon emissions. So one metric we can use to try and assess that is known as the greenhouse gas payback time. So this is the amount of time before the greenhouse gases produced when you're manufacturing the technology are actually repaid by the technology saving those emissions. So for a crystalline silicon solar panel placed in Germany, we have a greenhouse gas payback time of around kind of 3 years. And this has been slowly decreasing over the years through improvements in efficiency and also the amount of material which is used in the devices. However, more recently, the industry has moved to the Far East, mainly China and Taiwan, where the factories are being powered by very cheap coal. And this has actually reversed this trend and started increasing the carbon intensity of manufacturing these technologies. However, developments in materials, etc., has led to new types of materials which are being explored for making new types of PV devices. So second-generation technologies, also known as thin-film PV, most notably those based on the compound cadmium telluride, have recently been advanced as a solution to have proven to be a solution which is lower carbon to manufacture and less energy intensive when you're manufacturing. So the green line there shows that. Also, future technologies such as those based on polymers or dyes might have the possibility for actually driving this down even further, and thus providing us with really, really low carbon solar energy technology. So, as example there. So, however, taking this kind of static view of looking at the carbon emissions saving from a technology fails to take into all the temporal aspects in this. So renewables in general, and PV in particular, they require a very high initial capital investment cost, and the same goes for an environmental investment cost. So all your carbon emissions are actually right at the beginning, and then the carbon emissions are saved over the lifetime of the technology, typically around 25 or 30 years. However, if you have a very rapidly growing industry, then you might reach the situation where all the emissions you're producing to manufacture new PV technology is actually outweighing the emissions saved by existing capacity. So this could be looked at as your carbon investment to a transition to a new energy source. So part of my work, I'm trying to look into these issues a little bit, working on a model which tries to look at the consequences of a rapid transition to PV technology. And this aims to take into a number of temporal aspects in what's being avoided by the PV, and in terms of if it's a gas plant or a coal plant, etc., and also changes in the emissions associated with manufacturing the technology. So if we just look at an example of these results, so this model then calculates a carbon balance, so the balance between what's saved by existing capacity and then what's the greenhouse gases emitted from manufacturing that capacity. So if we take the example of Germany, so Germany, as I said, is been the biggest market historically, and has been developing its PV industry for the past 10 years or so. If we look at the carbon consequences of this, so this shows us that in that time, it's actually only now that they've realized real carbon reductions because of these policies. So it's actually quite a delay in the time before which real carbon reductions have been realized. However, in the long term, it will reduce huge amounts of emissions. So by 2020, Germany's PV policies will have saved the equivalent of around the annual outputs of carbon emissions from 60 coal-fired power plants. However, what if we look at new technology? So this is all based on PV capacity using crystalline silicon technology. However, if we look at... So this is the same graph as before, exactly the same, looking at the German case again. But what if we had geared our policies towards a lower carbon technology, such as I mentioned before, cadmium telluride, which is quite a mature second generation technology, uses thinner materials and is less energy intensive to produce. Then we can actually realize much more rapid reductions, and in the long term, much greater carbon emission reductions from focusing on that kind of technology. But this doesn't actually just apply to technology, but also where it's manufactured. So as I said before, manufacturers has largely gone to the Far East, to China and Taiwan recently. But if we actually had maintained policies which ensured it stayed in Europe, where cleaner electricity supply is providing the factories that make the panels and the systems, then we could also do the same kind of thing would realize, and we'd be able to realize faster carbon emission reductions and also greater carbon emission reductions in the longer term. Finally, OPV as an example of what we could do hypothetically, how smooth we could make this transition to a new energy source. So organic photovoltaics, or those based on polymer materials requiring very little energy to manufacture, could hypothetically provide a very, very smooth transition to this kind of to a clean energy system. Now, this also has implications on the cost. Crystalline silicon and cadmium telluride currently have very, very similar costs. However, as you can see here, they have much greater, there's a very big difference in the actual emissions avoided at a given point in time. So by focusing on certain technologies, we could provide a cheaper cost of carbon mitigation. And so, in conclusion, we can see that solar power technology has not always been motivated, has not developed in order to supply low carbon source of power, although it can do that. But understanding new types of materials and new technologies, which can help us further further development of PV, will allow us to hopefully reduce the cost of PV, leading to more capacity being installed, but also reduce the environmental impacts of the technology, which will lead to rapid and greater emission reductions. And yeah, in conclusion, focusing on the cheapest technology does not necessarily mean that we're focusing on the cheapest cost of carbon mitigation. So this kind of provides a motivation for actually looking at towards technologies which could provide us with cheaper carbon emission reductions through lower carbon manufacture. Okay, thanks very much.
What's the future of the solar industry going to look like with the onset of fracking and shale gas?
It's a good question. So again, we're looking at, if you take it just purely on a cost kind of consideration, then that's obviously going to massively destroy the economics of PV, which is kind of what's happened in America. But America is now also hugely growing its PV industry recently. But if we look at carbon emissions, then it depends what your motivation is. I mean, if your motivation is to rapidly reduce carbon emissions, you can do that to a certain extent with fracking, but then you're stuck in a high carbon scenario. I mean, it's still very high carbon technology, and it's possibly more high carbon than we actually know through leaks in methane gas, etc. But yeah, I mean, it definitely provides a challenge for kind of any kind of clean energy source. But I think it's still got a very promising future.